Hello and welcome. Today we're diving into how artificial intelligence is teaming up with data from space and the ground to change the game in predicting natural disasters like landslides, earthquakes, and volcanic eruptions. It's about getting ahead of these geohazards, making our predictions more accurate and timely. Think about the sheer amount of data we can gather now. Satellites give us the big picture, mapping ground movement with techniques like INSAR, spotting visual changes with optical images, and even detecting heat from volcanoes. Then, down on the ground, we have sensors like GPS stations, seismometers, tilt meters, and even simple rain gauges constantly collecting detailed, real-time information at specific spots. But having all this data from different sources in different formats creates a huge challenge. How do you make sense of it all? That's where AI, especially machine learning and deep learning, steps in. AI algorithms are incredibly good at finding complex patterns hidden within these massive datasets, patterns that humans might easily miss. So how does AI actually help? First, there's data fusion. AI can cleverly combine satellite images, readings from ground sensors, geological maps, and even weather data. It learns how all these different factors interact, giving us a much more complete picture of what's contributing to a potential hazard. Second, AI excels at pattern recognition. We can train machine learning models using historical data from past events. The models learn to spot the subtle signs or combinations of factors that often happen before a disaster. For example, AI might identify specific ground deformation patterns seen by satellites and GPS, combined with heavy rainfall measured by ground sensors, as a warning sign for an impending landslide. This leads directly to predictive modeling. Once trained, these AI models analyze the constant flow of data from satellites and sensors to forecast the likelihood, timing, location, and even the potential size of future geohazards. Deep learning models are particularly powerful here. Ultimately, this enhances early warning systems. By analyzing data faster and identifying precursors earlier, AI gives authorities and communities precious extra time to prepare and respond. This can save lives and significantly reduce economic damage. We're seeing exciting advancements and real-world applications already. AI is being used for landslide prediction by analyzing slope, soil, rainfall, and ground movement. It's helping improve earthquake probability assessments by looking at seismic data and crustal deformation. For volcanoes, AI integrates seismic activity, ground changes, gas emissions, and heat signatures to assess eruption risks. And it's even monitoring land subsidence by combining satellite data with groundwater levels, which is vital for cities and infrastructure. Of course, it's not without challenges. Integrating drastically different types of data is still complex. Getting enough high-quality training data, especially for very large but rare events, is tough. We also need to make sure the models are reliable and that we understand why they make certain predictions. Looking ahead, the future involves even smarter sensor networks, better satellites, and more advanced AI algorithms working together. The goal is real-time, autonomous analysis and prediction, ultimately helping us build more resilient communities capable of facing these powerful natural forces. Thanks for tuning in.